magnetization of ferromagnetic substance, paramagnetic substance when kept in an external magnetic field. We know that we have two terms. One term is magnetizing field. Magnetizing field is that field when a magnetic substance is kept in the field, then magnetic substance magnetized, and there is an induction of magnetic field in the magnetic substance when kept in such field, then such external field is known as magnetizing field. Suppose that this one is magnetizing field and now it is known as V0, and we know that V0 means here mu naught H. This H is the intensity of this field, intensity of magnetizing field. This is known as intensity of magnetizing field. When a ferromagnetic or paramagnetic substance is kept in this region, then a magnetic field is induced. Magnetic field is induced and denoted by Bm. And this one is also written as mu naught M. Here M is the intensity of magnetization of the substance or magnetization intensity. A magnetization intensity is the property of this material. It is the ability of this material, it tells the ability to acquire the magnetization when kept in magnetizing field. Now, in this case, the total magnetic field will be B equal to B naught plus Bm. And when we put the value here, this will be mu naught H plus mu naught M. And finally, we will obtain mu naught equal to H plus mu naught H plus M. And now it is B. And B equal to mu naught 1 plus H plus M. It is the final magnetic field of this material. And now magnetic field is magnetized. Suppose that if we have a hard ferromagnetic substance, say steel substance I have now, and in this case what we have, initially there is no any interaction between this substance with an iron substance. There is no any interaction. There is no any magnetization showing by this substance. Now it is a solenoid. We know that the solenoid having a large number of turns. Okay. Now we can see here the one terminal of this wire is connected to this one positive terminal, and another terminal is connected to the negative terminal of this external circuit. Now here this wire is wound over an insulating material, say a plastic pipe. Now there will be, when we apply some current, then this solenoid produces magnetic field inside it. When we kept this ferromagnetic substance inside this region, then after some time this ferromagnetic substance becomes magnetization. Practically we can see it. Now see here, when this material is touched with this paper pin, then there is no any interaction showing by this material. There is no interaction. You see here, nothing. There is no interaction. Means there is no any magnetization showing by magnetizing property showing by this material. Now, when we connect, see here, when we connect the one terminal of the solenoid to the external source, you can see here it is the battery animator, and it is the positive terminal of the battery animator. when we connect to the external source, and now the negative terminal means other end of this wire is connected to the negative terminal of this battery eliminator. Now when we switch on then it will supply the current to the solenoid, and now we know that the solenoid produces a current carrying coil produces magnetic field. So now it is also the first application of Ampere circuit, first application of what? Ampere circuital law. Ampere circuital law. Okay. When we put this material inside the solenoid and we supply current across the solenoid, now we will see that after some time this material becomes magnetized due to the magnetic field produced by this solenoid inside it. Then such magnetic field produced by the solenoid known as what? Magnetizing field. Okay, so now we will check here now this material becomes magnetized or not. So we will check here by putting this paper pin. If it will attach to this material, it means this material becomes magnetized. Now it is attached. It means what? Now this material becomes what? Magnetized. And if we switch off the current, then intensity of magnetizing field becomes 0. And after this, if this material will show the magnetizing property, then now this material behaves as residual magnet, and its retentivity and coercivity will be maximum. Okay, so now we will check when we switch off the external source. Now switch off, now magnetizing field becomes 0, but after some time what? It also continuously showing the interaction between this material and the paper pin, means it's showing continuously the magnetization. It means what? It is a hard ferromagnetic substance because its retentivity and coercivity is what? Large. So now we will check here also. Here also there is an interaction. So now this is the main key of what? The magnetization. Practically we can see here how a magnetic substance becomes magnetized.